Okay, hello everyone. So ang gawin naman natin ngayon, let us solve topics about DC motors and then yung question naman ay naghahanap ng torque, no? Ganun naman. So let's have the introduction, yung formula lang siguro na gagamitin natin sa mga problems. So una, syempre since torque ang pag-uusapan natin sa mga problems dito, so ano ba yung formula ng torque? So we have the formula for the torque which is ito, no, solving for the power that is equal to pi equal to 2 pi times the speed which is n times the torque, yung letter T natin, over 60. Wherein dapat ang ginagamit nating n ay RPM or revolutions per minute. Ngayon kasi engineers, no, yung minsan yung problem natin, nagtatanong what is the torque na nasa shaft or what is the torque developed in the armature. So magkaiba kasi yon. So kapag sinabi nating torque na nasa shaft, meron yun kapartner na power na nasa shaft. And kapag sinabi nating shaft pagdating sa motor, that is the output. So ibig sabihin pala kung tayo ay maghahanap ng torque na nasa shaft, ang gagamitin nating power is the output power of the motor. So sulat lang ulit natin yung formula, 2 pi times the speed. And yung torque na natin dito is the torque na nasa shaft and then divided by 60. And ngayon naman, engineers, no, if we will be using 2 pi times n and we will be talking about the torque developed in the armature or pwede rin natin sabihin T-dev over 60, ano naman ang kapartner nito? So, syempre, this is the power developed or the power in the armature. And di ba, engineers or everyone, no, na-discuss naman natin that the PDEV is equal to the product of the back EMF and the armature current pagdating sa motor. Diba? And pagdating sa generator, EGIA. So, reviewin lang ulit natin, di ba? Formula din naman ng E-back is the poles over 68. Number of poles, the flux, the speed, the number of conductors over 60 times the number of the parallel path. So, syempre yung letter A natin, that is either the multiplier times the number of poles kung siya ay lap, or ginagamit naman natin yung 2 times the multiplier kung wave winding naman. And then, isa pa, no, ang sikat na KVL pagdating sa shunt, di ba? Kasi minsan hindi na natin to dinodrawing yung motor. Kinakabisado lang or kabisado na natin yung KVL niya na VS minus IARA minus EBAC is equal to 0. So, ito syempre ginagamit natin yan sa shunt motor. And then siguro lastly for our introduction, meron din tayong isa pang formula solving directly for the torque. And that is equal to Z, number of conductors times the P, number of poles, times the flux, times the armature current, over 2 times the pi times the parallel path. Okay, let us now answer the problems, no, using this formula. So, basahin natin yung first problem. A DC motor takes an armature current of 110 amperes at 480 volts. So the armature circuit resistance is 0.2 ohms. The machine has 6 poles and the armature is lap connected with 864 conductors. The flux per pole is 0.05 Weber. So calculate the two questions. So number 1, calculate the speed. And number 2, we will be going to calculate the torque developed in the armature. So siguro, para masanay na lang tayo, no, magkaroon tayo ng diagram. So let us assume that the motor is a shunt motor. This is shunt motor. So this will be the branch of our armature. Andito ang e-back, and then nandito ang source natin. And then nandito naman ang shunt field. So ulitin lang natin, a DC motor takes an armature current. So the armature current is nandito. So kailangan maging tayo, ang mindful, tayo ay nasa motor na. So pumapasok na ngayon sa armature yung kuryente. Dati 'di ba sa generator kasi lumalabas galing sa armature yung kuryente natin. So ito, and then ang source voltage daw na yon na ginagamit niya is 480 volts. The armature circuit resistance, so the armature resistance is 0.2. And then lista natin sa ilalim yung mga wala sa diagram natin. The number of poles, 6. The number of conductors na binigay sa problem, 864. The given flux is 0.05. And again, no, nalampasan natin, the motor is lap connected. So we will be now solving what is the value of the N and what is the value of the torque developed in the armature o yung TDEV natin. Di ba engineers no or students, kung tayo ay naghahanap ng N, tapos nakita natin sa given merong letter P, flux, and Z, kasama niyan yung formula na E-back equals Pons over 68. Tama? So dito, let us try to isolate the letter N. So yung letter N pala, kung siya ang isosolve natin, cross-multiply natin, E-back, mamumultiply na ngayon yung dating nasa ilalim, which is 68. And then, i-divide natin ngayon yung P, yung flux, and then yung Z. So check natin ngayon kung magagamit na ba natin kaagad itong formula. Since we are looking for N, kailangan yung lahat ng nasa kanan, meron na tayo. But unang-una, cross out pa si E-back. Wala pa tayong E-back. Yung A natin, the parallel path, since we have written down that the motor is lap wounded, ang A niya is empty. So okay na to. No, meron tayong number of poles, number of flux, and number of conductors. So kailangan muna pala natin yung E-back. And di ba, sa ating DC shunt motor, we have the KVL. And that KVL is Vs minus IA RA minus EB is equal to 0. So substitute natin, I think given to. We have the Vs, yung source voltage, 480. We have the armature current, 110 amperes. The armature resistance, 0.2. And then minus EB equals to 0. Since si EB na lang yung natitirang unknown dito, we can now solve for that EB. So 480 minus 110 times 0.2. So our EB is 458 volts. So okay na ba? I think yes. Now we can now solve for the value of the N. Kasi meron na tayong EB. Sundan lang ulit natin yung formula na nilista natin dito sa taas. So the value of the EB is 458 times 60. Yung parallel paths natin will be multiplier times the number of poles. Since walang binigay kung siya ay simplex, duplex, triplex, syempre i-assume natin na simplex, kaya 1 yung multiplier. The number of poles, 6. And then divided by the number of poles, 6 again. The flux is 0.05. And then the number of conductors ay 864. So magkakaroon na tayo ng answer for our speed. 458 times 60 times 6 over 6 times 0.05 times 864. So the speed is 636.11 RPM. And now that proves our key answer, no? Yung RPM natin na answer. So let us proceed now to the second question. What is the torque? So again, no, can we solve for the torque using this formula? Di ba meron tayong formula directly solving for the torque? Z P plus IA over 2 pi A. O sige, dito natin ilista. So solving for the torque, we have Z P flux armature current over 2 pi times the parallel path. So yung Z natin is given 864. The number of poles also given 6. The flux is given then 0.05. The armature current nasa circuit natin 110 divided by 2 pi, and again we will be using MT sa ating parallel paths. 1 times 6. So, ang lalabas pa dito is 756.3. Okay, let us answer 864 times 6 times 0.05 times 110 over 2 times pi times 6. 756.3 Newton meter. So again, na-prove natin yung key answer natin. Nasaan? Ayan. 636 and 756.3. And now, let us proceed to the second problem. Determine the developed torque and shaft torque of 220 volts 4-pole series motor with 800 conductors wave connected, supplying a load of 8.2 kilowatts by taking 4.45 amperes from the mains. The flux per pole is 25 milliwebers and the armature circuit resistance is 0.6. So we have a series motor here pero walang binanggit na series field. So i-assume natin na armature lang ang meron. So this is the armature resistance. So wala muna tayong ilalagay na series field, no, kasi wala namang binanggit sa problem na mayroon. So i-assume natin na wala. And then this is the E-back. And then this is our source. So determine the torque developed of 220 volts na motor natin. So syempre ang rating ng motor natin, input voltage. Binigay din naman kasunod the number of poles, 4. The number of conductors, 800. Ano pa? Wave connected. So take note, this is wave connected. There is the output power, no, na 8,200 watts or yung 8.2 kilowatt natin. And then dito natin ilagay sa circuit, nagte-take daw siya. So from the supply, ang ampere natin dadaloy papunta sa armature with 45 amperes. Meron pang binigay dito, flux per pole. So sa baba na lang, no? The given flux is 25 milli. So 25 times 10 raised to negative 3 Weber. And then lastly, last given natin is the armature resistance 0.6. So let us solve dalawa yung question. So what will be the T-dev and what is the T-shaft? So again, engineers, the T-dev is also the armature the armature torque, di ba? And meron tayong formula yung ginamit natin from the first problem, Z times the poles times the flux times the armature current over 2 pi A. So lagyan na kagad natin ng note, we will be using 2M dito kasi wave connected siya. Okay? So dito na lang i-substitute natin sa part na to. Meron ba tayo lahat? I think yes, we have the value of Z, the value of P, the value of the flux, and the IA. So direct substitution only. 800, the number of poles is 4, the flux is 25 times 10 raised to negative 3. The armature current, yung nasa circuit natin, 45 amperes. Kasi series naman yon. So kung ano yung source current, armature current na din. So time over 2 pi. And then yung parallel paths natin ay 2 times the multiplier 1. So wala naman ding binanggit, di ba? Kung simplex, duplex, or triplex. So 800 times 4 times 25 milli times 45 over 2 times pi times 2. So our first answer is the T developed 286.48. 286.48 Newton meter. So this is the T developed or the torque developed in the armature. Next, kung pupunta naman tayo ngayon sa shaft, no, for the shaft, paano natin to isosolve? So ito, engineers or students, yung formula na sinold na ginamit natin dito, that is for the armature. No? Ngayon, paano naman kapag sa shaft? So, gamitin natin yung formula ni power. Di ba? Kailangan, kung nasa shaft tayo, ang involved na power dito is power in the shaft, and this is equal to 2 pi n, and then ito yung hinahanap natin, torque na nasa shaft, over 60. And take note, again, kung nakalimutan natin, the P shaft is also the output power. So given kasi yon, tama. So let us check, okay? We will be checking the P shaft kasi meron siya. So we are questioning what is the torque dito. Ang problema naman natin ngayon, wala pa si N. And if we will be looking for N, sino pa bang formula? Yung ginagamitin natin ng N, syempre wala tayong sawa sa ponds over 68. So this is poles, flux, yung N na hinahanap natin, number of conductors, and then 68. So dito sa formula na to, kine-question natin what is N, di ba? Para magamit natin sa itaas. So check natin, ang nakikita nating wala ngayon is the EBAC, no? Wala yung EBAC. Tapos, meron naman na ito, number of poles, number of flux, number of conductors, and the parallel path. So, ngayon, alam na natin, no? Mukhang nakikita naman na natin saan tayo papunta. We will be using the KVL of our shunt motor. And that is Vs minus Ia RA minus EB is equal to 0. Kasi dito natin masosolve yung E-back natin. What is the source voltage? Ano ang sinusupply sa motor? 220 volts. Ano ang kuryente sa armature? So nasa circuit yon. Sinulat natin 45 amperes. And then the armature resistance is 0.6 minus the E-back. This is equal to 0. So we can now solve for the E-back. 220 minus 45 times 0.6. So the E-back is 193 volts. Okay, makakabalik na tayo ngayon. Since nakuha na natin yung E-back, we can now continue getting the value of N sa formula ni Pons over 68. So substitute natin. The E-back is 193. This is equal to the number of poles, which is 4. The number of flux is 25 milli times 10 raised to negative 3. We are looking for N, and then the number of Z is 800 divided by 60 again times 2M. Nasa wave connection tayo. Kaya 2 times 1. We can solve for the value of n muna. 193 times 60 times 2, cross-multiply natin, and then i-divide natin lahat ng katabi ni letter n. 4, 25 milli, and the 800. So, ang n natin ngayon is 289.5 RPM. So, lastly, we can now solve. So, finally, no, we can now solve for our final answer. So, dito na lang siguro sa space, no? Sa space na lang natin ilagay. So, therefore, solving for our shaft torque, ang output power natin is given 8,200. This is equal to 2 pi. Ang na-solve nating n is 289.5. We are looking for the shaft torque, and then this is divided by 60. So finally, we can now solve for our shaft torque. So 8,200 times 60, and then again, i-divide natin lahat ng katabi ni shaft torque. So 2 pi times 289.5. So we have here 270.48 Newton meter. Is this the same with our key answer? So yes, our key answer is 270.5 pagdating sa shaft. No. And then last problem. A 4-pole 220-volt shunt motor has 540. So since shunt motor yan, umpisahan na natin yung pag-drawing ng shunt motor natin. And then habang binabasa natin yung problem, so doon na natin ilagay, no, yung given. So this is the branch for the armature. So nandito ang e-back natin. And this is the source. And then the shunt field. So a 4-pole. So sa labas muna, the P is equal to 4. 220-volt motor. So ang rating ng motor, that is the source voltage. Meron siyang lap wound conductors, wherein the value of that conductors or Z is 540. They are lap wounded. Or lap wound, sorry, lap wound. So it takes 32 amperes from the supply mains and develops. Meron naman dito 32 amperes, no, from the source. From the supply mains and develops output power. So we have here PO, output power, which is 5,595 watts. And then the field winding takes 1 ampere. So dito, syempre, papalabas pa din yan, papasok sa field na meron tayong 1 ampere. So the armature resistance is 0.09. So the armature is 0.09. And then the flux per pole is given then. So we have the flux na 30 milli. And then the question is, what is the value of N and what is the shaft torque? So una, targetin natin makuha si letter N. And siguro napapansin niyo, no, or nasasanay na tayo, kung tayo ay may hinahanap na letter N, dapat merong e-back. Diba? Nasasanay ba tayo doon na kung tayo ay may hinahanap na N, dapat merong e-back? And ayun yung wala pa sa ating problem. Kaya unahin na kagad natin, since kompleto ang currents natin, yung tatlong currents, the source current, the armature current, and the shunt current sa ating diagram. Siyempre, this is the armature current. Let us proceed to KCL. Di ba alam naman natin, pagdating sa motor, yung IA na ngayon is equal to the source minus the shunt current. So yung source current natin is 32, yung shunt current natin 1. So we have the armature current as 31 amperes. Next naman, if we will be using KVL, di ba, magki-KVL na tayo dito so that we can find the value of the back EMF. So Vs minus IA RA minus the E back is equal to 0. To substitute 220 minus 31 our IA, the RA is 0.09 minus E back is equal to 0. So we can find the value of the E back dito. So the value of EB, the back EMF is 220 minus 31 times 0.09. So 217.21. So 217.21. So dahil meron na tayong EBAC, pwede na natin ulit gamitin yung cons over 60A, di ba? The EBAC is equal to poles times flux, speed, conductors over 60A. So substitute na lang siguro sa ilalim. So the EBAC is 217.21. The number of poles is 4. The flux is given as 30 milli, so 30 times 10 raised to negative 3. We are solving what is the value of the letter N, tama? And then, the value of Z is 540. Over natin to ngayon sa 60A. Take note natin, ano ang gagamitin nating A? So, we will be using MP kasi lap wound ang ating machine, no? Lap wound daw. Okay, wala ulit binanggit about the multiplier. So, assume natin na 1. And then the number of poles is 4. And then, this will be our speed. So, 217.21. So, lahat ng nasa ilalim sa kanan, i-cross multiply natin, kaya times 60 over 4. Over 4. And then, i-divide natin lahat ng katabi ni letter N. 4 times 30 milli times 540. Nakamultiply dapat mo. Ito, nakamultiply. So our value for this speed is 804.48 RPM. 804.48 RPM. And that is our key answer. Makikita naman natin. And then finally, so let us now solve for our torque na nasa shaft. And di ba, engineers or students, kapag nabasa natin na shaft torque ang hinahanap, yung P agad na formula. The output power is equal to 2 pi N T shaft over 60. No. Output. Basta shaft, output. So the output power na ibinigay is 5,595. This is equal to 2 pi. Our speed is 804.48. And then let us solve for the shaft torque. And then over 60. Saan na? Okay, shift solve na lang natin ang torque dito. So let us shift solve the value of the torque. Or ito, i-multiply natin. 5,595 cross multiply 60. And then lahat ng katabi ni torque, i-divide natin. 2 pi tsaka 804.48. So, ay sorry, nakaano to. Tama, tama. Ano ulit? 66.41. So 66.41 Newton meter. So tama ba ito ang nasa key answer? So yes, 66.5. 66.5 Newton meter. So I hope no, medyo nadalian tayo sa question na torque. No, kasi syempre dapat master muna natin yung KCL and yung KVL na ginagamit natin kapag tayo ay nasa DC motor na. So nagkaroon lang tayo ng karagdagang formula about the torque and the output power.